Yes. Hey, welcome back. Since I just sorted array to binary search tree, it makes only proper sense that I solve the problem. Sorted linked list to binary search tree. And again, this question is 99% similar to the previous question in the way that you're given a linked list now, but it is sorted and you have to convert it to binary search tree. And yeah, let me just tell the most nice implementation of this. It is nothing but to convert the entire linked list to an array and then just run the previous algorithm which I had mentioned. And since that is pretty straightforward, I'll not be going forward with typing up that approach, and let's directly go through how to implement actual actual based from actual linked list only, like not converting and all. So what we did in the previous approach was that first we took the entire array and then we found the middle element, which was nothing but 4, and we set that as the root, and every element left to the 4, we took that and then we found the middle of that element and set that as the root of I set that as the left child of 4. And every element to the right we took, and middle node of that and the middle element of that we set as the right child to 4. And then what we did was that we again took every element to the left of 2, and we set that the middle of that is nothing but 1 to the left child of 2, and every element to the right of 2 and to the left of 4, we took that, we found the middle of that, and we set that to the right child of 2. And we continued the same process with the node 6 also. And the difficulty is that we have to implement that in linked list now. We can't use an array and directly do middle is equal to left plus right by 2. And so what you will do? First you have to find middle. And finding middle itself is a problem in Gibbs setting of a linked list. And for that you use an algorithm called Floyd Warshall algorithm, or it's called tortoise and hare algorithm also. So what we'll do, we'll use that to find the middle node. And then during that process itself, we will do one more thing, which is to actually split our linked list in that place so that for future computations, it won't give any issues. So first, what we will do, first of all, we'll get like the utils part out. So we'll just have a Floyd Warshall finding part, middle node finder, and you'll be just given a head. So what you'll do, you'll have, yeah, and while slow exists, no, while fast exists, and the fast dot next exists. So what you will do, fast, and if you do that, you are not correct, because fast should move two places, and dot next, and slow should only move one place. And after doing this, what we will do, before doing this, we will just keep a track of previous pointer also, which is actually slow for now. And this is mainly required because after we reach 4, we have to cut the tie between 3 and 4, so that those are considered to be two separate linked lists. If you don't do that, what will happen is that again for like you take 4 and you do convert it to your node, like what you call root node. But again, next time when you're searching, what will happen is that it will again search for everything from 1 to 7 itself, and you will again be left with 4. And it will recursively go in an infinite loop, adding 4 as the left child, 4 as the right child, 4 as the root, 4 as the left child, 4 as the right child, 4 as the root, so on. And you obviously don't want that. So we'll have a previous pointer also, which will actually break the connection between 3 and 4. And so what we'll do, only if the previous exists. So 3 dot next, we'll set it to none, and then you will return slow. So the make this sure of one thing, and that thing is that your actual linked list has now been manipulated. Linked list is a passed by memory, not passed by reference, and the data present in the actual memory itself is being manipulated. So just be careful of that. So now what we will do, we will go on with our actual core of the algorithm. So we'll call self dot build a tree like before only. Just but now we'll just pass in our head and we'll return it also. So we'll define it also, define, which is nothing but which will take the head value, and it will also take the self value. And so now what will happen is that if by any chance your head is not there, so what does that mean? So if your head is not there, that means only one thing, and that is that your linked list actually was empty, like you were not given any node, and you have to explicitly handle that, or else what will happen is that you will be left with some null pointer exceptions, and you don't want that. So let's just do that. So if by any chance, if the head is null, if not head, so what you have to do, you have to return none. Again, this is the base case. Or else what you will do, you will find the middle node. Middle node is nothing but the Claude algorithm of the head node. And by any chance now, if the middle node becomes equals to head, that means that you have a condition where your linked list was too small. In other words, you are given only a single node or something. That's why the middle node itself is being treated as a head node. And so what you have to do in that case? In that case, you have to return uh, the root, but you have not yet built the root. So let's just build the root also. So root is nothing but the tree node of the head dot data. And yeah. So now what happened is that you have you had only one node, like while passing through to the head. And so what happened was that since it was single node, you directly created a node of that and tree node of that and returned it. Or else what you have to do, since now you have the root node, so you have to break up your linked list into two halves, and that has thankfully been done over here itself. So now what you will do, now what you have to do is to create the left and right child of the root node. So root dot left is left and root dot right is also left, and then just returning the root is also left. So what is the root dot left value? Root dot left value is nothing but the build tree of the value root. My bad, it's not root, it's head. So why is that? So while splitting it only, and while finding the middle node only, you made sure to cut the connection between the links. So if you consider this one, after you found the middle node, which is okay, let's consider this one. As soon as you found the middle node 4, you made sure to cut the link between 1, 2, 3, and 4, 5, 6, 7. So what happened is that you this part has become your left half now, and this part will become your right half. So like this part, as in you should never pass this entire part. You will see this entire part. If you pass this, you will get wrong values. But this part is your right node, and you made sure to cut it over here. So this link has been cut over here. Yeah, this link has been cut over here. And so what you did, you passed that part. So 1, 2, 3, which has been cut, has been passed as the left half, and self dot you have to pass the right half, which is nothing but the middle node. And if you do this again, you're wrong because your middle node will still be pointing to 4. You don't want 4, but you want to pass the next node of 4. So middle node dot next, and then you return root. And I think this is all it. Invalid syntax. Oh, why did I add another self code? I don't know. Okay, and we have made some small blunder somewhere over here. Let's just go through the code once. So pass and pass dot next. Slow is equal to slow dot next. 1, 2, 3, 4, 5, 6, 7. 1, 1, 1. Okay. Mm, let's just bring it to our top to see what is happening. So you have your build tree function. If not head, you're returning none. Or look what you're doing. You're finding the middle node. Uh, Lord, you're passing the value of head, slow, fast, and previous. Previous is equal to slow, slow is equal to slow dot next, fast is equal to fast dot next dot next. And if slow dot next exists, yeah, this was standard stuff. And if head is equal to middle node, you're returning the root equal to yeah, middle node dot next and return root. And only if tree exists, we are breaking the connection between tree and the next node. So what is wrong over here? If you are passing the head only, yes, and you are getting that. And if there is no head, you are returning none. So, okay, I got to know. I don't know why I'm doing head data over there. It is with middle node dot data. Okay, that was very confusing. And yeah, now it's working. That was what was expected. Yeah, just don't make such small mistakes. Since I was passing the middle node again and again, it just created a six like a tree with six nodes, the number of nodes which is actually present in our linked list, but all over the middle, all over the head node itself. And yeah, and that's all for it. And thank you for watching. And goodbye.